Aeronautical Engineer job role, practical experience guidelines and AI contribution. As an aeronautical engineer, you will embark on an exciting journey at the intersection of aviation and cutting-edge technology. Your role will be crucial in designing, testing, also implementing the aircraft of tomorrow. By integrating AI as well as sustainable solutions, you will help shape the future of flight, making it safer, more efficient, along with environmentally friendly. Aeronautical engineers are innovators, constantly pushing the boundaries of what is possible in air and space. Travel. Job description. Aeronautical engineers specialize in the design, development, testing, and production of aircraft, spacecraft, satellites, also missiles. They focus on improving fuel efficiency, flight safety, as well as environmental impact. Working across both military and commercial sectors, they integrate the latest advancements in AI, autonomous systems, including sustainable technologies into aviation. Industry profile. The aeronautical engineering industry plays a critical role in transportation, defense, and space exploration. With a growing focus on eco-friendly solutions, the industry is seeing the integration of AI, also automation in areas such as unmanned aerial vehicles, UAVs, as well as autonomous navigation systems. Emerging sectors like space tourism, including urban air mobility, UAM, are opening new opportunities in aeronautics. Key responsibilities. Aircraft design and development. Conceptualize, design, and test new aircraft models with a focus on performance, safety, also environmental sustainability. System integration. Work on integrating propulsion, avionics, as well as communication systems within aircraft and aerospace vehicles. Simulation and modeling. Use advanced software to run simulations of aerodynamics, including structural performance. AI in aviation. Implement AI-driven solutions for predictive maintenance, navigation, along with optimizing fuel efficiency. Sustainability efforts. Innovate greener technologies, electric and hybrid propulsion systems, as well as materials that reduce emissions. Collaboration with R&D. Engage with research institutions and corporations to stay ahead of technological advancements. Theoretical research. Investigate advancements in aerodynamics, propulsion systems, and AI applications in aviation. Publish findings related to future aircraft technologies in industry conferences, also journals. Experimentation. Design and conduct wind tunnel tests as well as flight simulations. Work closely with AI algorithms to simulate different flight scenarios along with optimize aircraft systems. Collaboration with academia. Collaborate with academic institutions for cutting-edge research on topics like autonomous systems and space exploration. Innovative solutions. Develop breakthrough technologies that enhance performance, reduce environmental impact, including increase the safety of air travel. Implement AI for autonomous flight, also AI-powered aircraft navigation systems. Staying updated. Continuously research the latest trends in AI, machine learning, as well as aerospace technology. Keep abreast of environmental regulations and innovations in fuel efficiency. At the glance. Your interest. Passion for aviation, space exploration, AI, and sustainability. Entry qualification, bachelor's degree in aeronautical or aerospace engineering, with a preference for advanced degrees in AI, robotics, or sustainability. Lifestyle. Office-based work with opportunities for field testing and research in high-tech environments. Location. Aerospace companies, government research labs, or academic institutions, occasionally in flight test locations. The realities. Intense focus on innovation, teamwork, and adherence to strict safety regulations. Soft skills guide. Ability to work effectively in interdisciplinary teams that include engineers, scientists, and technicians. Strong leadership skills for directing research and development projects. A methodical and analytical approach to problem solving and testing. High proficiency in IT and software, including AI tools, simulation software, and networked systems. Strong commercial awareness to balance innovation with cost-effective solutions. Career path. Trainee. Begin as a trainee with aerospace companies or government agencies, learning about aircraft systems and industry standards. Graduate engineer. Gain hands-on experience working on aircraft design, testing, also development. Postgraduate/researcher. Pursue further education to specialize in fields such as AI in aviation, unmanned systems, or space technology. Aerospace systems analyst. Focus on integrating advanced systems as well as testing their functionality. Further careers. Aircraft design architect. Lead the conceptual design of next-generation aircraft, UAVs, and space systems. Senior aeronautical engineer. Manage large-scale projects and teams focused on AI integration, also sustainable technologies. Aerospace consultant. Provide expertise to government agencies along with private sector companies, particularly in future air mobility and sustainability efforts. Aerospace engineer. Focus on spacecraft and deep space exploration technologies. Avionics engineer. Specialize in the electronic systems used in aircraft, also spacecraft. Systems engineer. Work on the integration as well as optimization of various aerospace systems. Data analyst, aviation. Analyze aviation data for trends in safety, efficiency, including performance improvements. AI specialist, aviation. Implement AI for autonomous flight systems, predictive maintenance, along with fuel optimization. Here's a list of practical experiences essential for an aeronautical engineer, along with how to learn and develop these skills using the latest or updated technology. Aircraft design and 3D modeling. Practical experience. Learn how to design aircraft components, systems, and structures using computer-aided design, CAD, also modeling software. How to learn. Software. Use tools like AutoCAD, CADIA, SolidWorks, or ANSYS to create 3D models as well as simulate aircraft performance. Online courses. Platforms like Coursera or edX offer specialized courses in CAD including 3D modeling for aeronautical engineering. Project-based learning. Join engineering clubs or competitions, like AIAA design competitions, where you can work on actual aircraft designs. Aerodynamics and fluid dynamics simulation. Practical experience. Analyze how air interacts with various aircraft structures to optimize designs for performance and fuel efficiency. How to learn. Software. Tools like CFD, computational fluid dynamics, simulators, e.g., Fluent, OpenFOAM, allow engineers to simulate airflow, also fluid dynamics around aircraft. Courses. Take specialized aerodynamics as well as CFD courses from institutions like MIT OpenCourseWare. Simulated projects. Engage in simulation projects where you can model fluid dynamics to improve aircraft designs or learn through virtual wind tunnel tests. Finite element analysis, FEA. Practical experience. Learn how to use FEA tools to assess the structural integrity and durability of aircraft parts, also assemblies. How to learn. Software. Use ANSYS or Abacus for finite element analysis of stress, strain, as well as deformation in aircraft components. Certification courses. Enroll in courses like FEA for aerospace on platforms like Udemy or Skillshare to get hands-on experience with FEA tools. Case studies. Analyze case studies of aerospace components structural testing for real-world application. Artificial intelligence in predictive maintenance. Practical experience. Learn how to implement AI and machine learning algorithms to predict the maintenance needs of aircraft, preventing downtime. How to learn. Software/tools. Familiarize yourself with Python, MATLAB, or AI platforms like TensorFlow to develop predictive models. Online learning. Take specialized courses on AI for predictive maintenance from platforms like Udacity or DataCamp. Practical application. Participate in AI-related hackathons or projects where you develop algorithms to predict aircraft part failures using sensor data. 5. Autonomous flight systems and UAVs. Practical experience. Learn how to design and work with autonomous aircraft systems, including unmanned aerial vehicles, UAVs. How to learn. Simulations. Use software like MATLAB Simulink for UAV flight simulations, also autonomous system design. Drone development kits. Start hands-on projects with drone development kits such as Pixhawk or Ardupilot to build as well as program UAVs. Workshops and courses. Attend workshops or take online certifications in UAV design and programming offered by providers like Udemy, Coursera, or universities. Flight testing and data analysis. Practical experience. Conduct flight tests to gather data on performance, stability, and safety of aircraft. Analyze this data to refine aircraft designs. How to learn. Simulation software. Use flight simulation tools like X-Plane or Flight Gear to simulate flight conditions, also data collection. Data analysis. Learn how to process as well as analyze flight test data using tools like Python, MATLAB, or R. Flight testing internships. Join internships or apprenticeships with aerospace companies where you can participate in real-world flight testing along with data analysis. Propulsion systems engineering. Practical experience. Learn about the design and development of aircraft propulsion systems, including jet engines, also newer technologies like electric propulsion. How to learn. Software. Use propulsion simulation tools like GasTurb or NPSS to model engine performance as well as optimization. Advanced courses. Take specialized courses on aircraft propulsion systems from providers like Coursera or edX. Hands-on experience. Work with small turbine engines or electric propulsion systems in lab settings or workshops offered by aerospace schools. Materials science for aerospace. Practical experience. Understand and work with advanced materials, including composites, also lightweight alloys used in aircraft construction. How to learn. Materials testing. Gain hands-on experience in materials testing labs or through software like CES EduPack for materials selection. Online courses. Take courses on aerospace materials from platforms like FutureLearn or edX. Projects. Participate in aerospace material development projects, focusing on sustainability as well as innovation, such as using composite materials for lightweight aircraft. Avionics systems integration. Practical experience. Learn how to integrate advanced avionics systems for communication, navigation, and flight control in modern aircraft. How to learn. Tools. Familiarize yourself with avionics design tools like LabVIEW, MATLAB, or Xilinx for FPGA programming. Take avionics-focused courses offered by platforms like MIT OpenCourseWare, or industry-specific avionics workshops. Certification. Obtain certification in avionics systems through recognized programs like FAA's Avionics Technician Certification. Sustainability and green aviation technologies. Practical experience. Gain experience in developing and implementing sustainable technologies in aviation, including electric propulsion, biofuels, energy-efficient designs. How to learn. Online learning. Explore courses focused on green aviation technologies, also sustainability from platforms like FutureLearn or edX. Tools. Use design tools to model sustainable aviation solutions, such as ePlan for electric propulsion or Homer Pro for hybrid energy systems. Internships. Join sustainability projects or internships with companies like Airbus or Boeing that are pioneering green technologies in aviation. These practical experiences will help you develop a strong foundation in aeronautical engineering while also leveraging the latest technologies to stay relevant in this fast-evolving field. 8. A contribution to autonomous transformation for aeronautical engineer role. Thank you for listening. For more information related to career path, job role, or description, follow our channel Career Quest.